Hello everyone, this is Moin. Today we are going to learn an efficient algorithm which is called HeronOfAlexendria to find the square root of a number. For doing that, we need to write a function called which is type double, and the name of the function is HeronOfAlexendria, and we pass the parameter which name is double and type is double and name is value. However, here we are going to check the user input value is positive or negative. If the value is negative, the square root of the function will become complex number, so we convert the negative value into positive. So for doing that, if the value is less than 0.0, we are going to update the value calling another function which is app's value, and we pass the value into that function. We need to write this function here. This function simply return the positive value of the given value. Means if the given value is negative, it will return the positive of it, like this. If the value is 0.0, return minus value, which will be positive. Otherwise, return the value. Okay, after doing this, we are going to write some variable here. Actually, we are going to need this variable for doing our program. Here we made a guess which is 1/3 of the value the user given value. Okay, after doing this, we're going to write a loop while it is true. So it's simple like that. Error is guess into guess minus value, and we pass the error value into this app's value function to make the positive of this value. So for doing that, this is simple. After doing this, we are going to check if this app's error is close to this epsilon or not. So we are going to write if app's error is less than equal epsilon. If this consider this condition, it will simply return the guess. Otherwise, it will update the value of the guess into this. Guess plus value divided by guess, and the whole thing divided by 2. Pretty much this, like this. Yes, this is it. In the main function, the user is going to give the value to the program. So for that we are going to need a variable called double number or double value, whatever you want. Printf, enter the number. Okay, then number is equals to get. This get double is the function of CS50 library which is written here. It will get the value from the user. Then we are going to print our result. The square root of the number is, as we use double, we are going to write long float. Yes, and the long float is the result of this function. So we pass the number here, then do the maths, and then we get our result, and then we print it like that. Let me run this. See, the program works correctly. So here's the thing, in linear search, this guess value is initially 0, and it will update the value from 0 to 5, and from 0 to 5, and the update reference, what is it, the increasing amount of the value is 0.0001, and then it will find from 0 till 5, it will find for every number and for the error, and till the error is close to epsilon, it will repeat the thing again and again and again. That means it will take so many steps to do these things. In the binary search, we guess the value, we initially guess the value which is mid value, which is the average of lower limit and the upper limit. In this case it is 2.5, and after that we use the guess value to find the error. If the error is close to epsilon, it will return the guess, which is our result, and if it is not, it will check if the error is greater or less than the 0. If the error is greater than 0, then it will search in the first half from 0 to 2.5. it will update the guess, it will update the lower limit into 0 and the guess value into 2.5. but if it is not going to greater than 0, then it will search in this area, in this half, and it will update the lower limit into 2.5, which is our guess, and the upper limit is 5, which is initial upper limit, and then it will repeat the system again and again until it finds its result, until it finds the error which is close to epsilon, and return the guess for that error. But in HeronOfAlexendria, we initially declare the guess 1/3 of the value, and we find the error. We check if it is close to epsilon. If it is close to epsilon, we return the guess. Otherwise, we will update the guess into this and repeat the system. It will take less steps than these two algorithm, so this is efficient. Okay guys, we are done here.